mistake. You have the presentation on the computer already. It's a successful story.
I guess. It's a good story. Definitely a good story. L'avevo messo ormai sul browser. Sì, l'avevo messo sul browser. Okay. Okay, thank you. I guess I can start. Yeah, I guess I can start. Okay, so my name is Niccolò Ruggeri, and I'm just a former data science student here in Padua. So today I won't give you any more technical detail about the degree. It will just be a story about me studying data science and where I went further after this. So it's just an example to explain what one can do during and after the data science course. Before I start with the whole story, something about me. I was born and raised in Padua, academically speaking at least. So I studied mathematics at the Department of Mathematics, and my thesis was just in probability, which was really cool already. And then I just decided to go on with the data science course, which you also are really gonna take after this presentation. With a final thesis in variation inference. We'll explain a bit about this afterwards. And in hindsight, I guess it was a kind of coherent story. Mathematics was a good playground for me. It was really interesting, and then going on with data science just allowed me to apply many of the things I learned during my bachelor for the master. Now I'm currently doing a PhD at ETH Zurich, which is a nice university in the northeast of Switzerland, and Max Planck Institute, which is another very nice institution in the southwest of Germany. So it's a shared PhD between these two institutions. And here, this is where I go with what I did during my master. So during my master course, what I did, what I studied, and afterwards I'll tell you about what I'm doing at the moment as research. So before we start my data science journey, I would like to highlight that this is my data science journey, which means that, as you probably have gathered from all the presentations before me and the professors, data science is really huge. And I guess it's really hard to know everything about data science altogether. And this is a way to say, yeah, this is one of the possible paths. One can take whatever. Many of my former peers during the data science master took different paths in life. And I know for a fact that they're really happy just taking a different way, going somewhere separate. With that said, I'll just explain you what my courses were during my master, which I think that they highlight the backbone that also Professor Rinaldi explained before. And even without coordinating about this, I guess I came up with the same separation of courses in big topics. So there was some mathematics, the basic mathematics you need for data science, and in my case, a bit more tailored towards numerical methods for big data and machine learning in general. So I took stochastic methods course, optimization taught by Professor Rinaldi at the time, and some other courses in mathematics. And then, of course, other stuff came from more applied to machine learning, so more tailored not to general mathematics, but machine learning applications. And these were the algorithmic methods and machine learning course, which you also have. Statistical learning course, which is very similar to the one I took, I think, and the human data analytics with Professor Rossi at the time. And after I went on with the other skills that I guess you can expect from a data scientist. So my T skills, some coding definitely, and this is basically what's encompassed by the fundamentals of information system course that's going to be taught in the first year. And this is really useful. For example, I'll show you one of the projects I'm working on at the moment where I basically exploit almost all of these. And then finally, some more applicative courses where you try to exploit all this knowledge and apply it to some data coming from different scenarios like biology, social science and finance and so on. Okay, so this is kind of what I learned during my master, and then there's a part of what I did during my master. So this is the first internship I took in between the first and second year. It was the summer between the second and third semester. And I guess I have to point out, this does not count as my internship during master's. This is a separate thing, which I just decided to do on my own. It was kindly supported by the university's the Erasmus traineeship program, which you can apply for many times. I think there is a maximum of months you can obtain during master, but I'm not quite sure what the maximum of months is now at the moment. But the experience was very fulfilling. I went to London working with this small startup that were called Deary, and they're still there, still working on this stuff. And the idea was to build a mobile app, basically, where they take some messages and through some natural language processing and other machine learning techniques, they try to classify the messages. This is what is also called, at least in their application, this is called sentiment analysis. And I guess in terms of skills that I acquired during the internship was a lot of extra coding, building on top of the basics I had learned in Python during my bachelor in mathematics and during the course I took during the data science master. I had to code a lot, and then there was some extra machine learning to do on top after we came up with the first simple structure for the code base for the start. This was really fun, It was amazing, and I guess it's a good experience overall. And then second, my actual formal internship at Max Planck Institute for Intelligent Systems, which is also where I'm taking part of my PhD now. This is the formal internship that you need to have for your degree in data science. And at least during my thesis now, and I'm switching a bit my research topics. I'll tell you about them more afterwards. But in my thesis, I was working on network science, which is basically a branch. It's a branch a bit outside machine learning. It's the main core of machine learning, where you try to model big data through the usage of graphs and networks, and some probabilistic learning, which was in my case some Bayesian inference and some Bayesian modeling on top of networks and also outside the network modeling scenario. Okay, so this was my experience. It was real fun. My two experiences during the master and my courses, and now just again as an example of what one can do if they want to during the data science master and with the data science skills they acquire here. Some projects I'm working on or have worked on in the past. Which I think I chose because they're very explicative of what one can do, and they're very representative of something I like from the data science skills. Okay, so this is one first project I'm working on at the moment. And this still falls under the network science kind of label, I think. I'm working on this with my supervisor from Max Planck at the Bacco, which I got to know during my internship for my master thesis. And the idea here is that you just go on Twitter and try to sample some data. As you can imagine here, there's a lot of coding involved. And the idea is that after gathering all the data from Twitter that we need, with a huge code base, we're still working on the code at the moment, which involves a lot of Python, of course, scraping the Twitter network with different APIs or by building the scrapers yourself. And a lot of database because there's data to be handled. Well, after this stage, the idea is that we're gonna try to come up with a probabilistic model for modeling how hate speech propagates through the Twitter network. This is real fun because if you like coding, this can be real fun. I guess a nice way of spending time. And after the data collection phase, we're gonna do some statistical modeling. We're gonna model the Twitter network as a network, as per name, and try to see if our probabilistic models manage to feed the hate speech propagation on the network. Of course, this is not an idea of ours. One does not just come up with this by themselves. We have collaborators, and especially some sociologists in Santa Fe Institute, which are really interested in how hate speech in general, more on the sociological perspective, propagates and affects real life. So this is the first stage of a multi-stage project where first the probabilistic model will try to explain how Twitter behaves in terms of hate speech propagation, and then we're going to connect with further probabilistic modeling this hate speech propagation with real life crime data. So the idea is that we're going to see if there's a correspondence or at least some correlation between the Twitter network, which is completely virtual, as you can imagine, and the real life crime data, which we have from our collaborators and sociologists in Santa Fe, and all together try to come up with an explanation. of how these phenomena behave. So this is the first project I wanted to mention because I think it's very explicative. You see, there's a lot of coding, there's statistical modeling, there's inference, there's a lot going on. And this is all stuff that I guess at least the basics I gathered from my data science course. So this is really interesting. And then I would like to tell you about some other things I'm doing, some other projects I'm working on. This still went with my supervisor, Katerina de Bach and Max Planck. This first idea is just working on probabilistic learning. This was my master's thesis, which was separating two things, the network science part and the probabilistic learning part. And here, this is an example of something that's very trendy at the moment in machine learning, which is called variational autoencoders. This is basically the classical version of Bayesian learning and Bayesian inference, which is more, I would say, in the old days, was more tailored towards pure statistics and pure statistical modeling. And nowadays it's moving a lot also towards machine learning. And this is a nice intersection between what was more a core machine learning and more a core statistical kind of scenario. And you merge them through Bayesian modeling and deep learning. So variational autoencoders fall under this category of models that try to model densities in high-dimensional data. Which you're also going to see if you take some of the electives in the courses of the Master's Data Science Master. Because the idea here is that, as was explained before nicely during the other presentations, if you have big data, it's really hard to come up with a proper algorithm to model the data and to classify the data, but at the same time, it's really hard to come up with something, for example, that can generate realistic faces just without just by hard coding the algorithm that generates the faces. So variational autoencoders fall under this category of models altogether that try to model high-dimensional data and try to generate the data. So these, for example, are not real faces. These are faces generated by the variational autoencoders data in 2013. But generate new faces which don't belong to anybody, they're just faces made up from the computer. And as you can imagine, this was 8 years ago. By now, the generation is crazy. They're really good. And the idea here is that variational autoencoders are a really nice intersection between deep learning and Bayesian modeling, but they come with limitations and with approximations. So in general, one can come up with any really nice and fancy Bayesian model or any statistical model for that matter. But then the difficulty is to come up with inference. So the difficulty is to come up with the right weights or parameters in general. Something that, at least in the basic form, you're gonna learn during the statistical learning course, that allow your model to generate or explain the data properly. And since variational autoencoders have millions of parameters, because the neural networks in the end, on top of some stochastics, they come with limitations and approximations. And the idea here is that during my project, I wanted to improve on the DAE learning procedure by coming up with better approximations that allow you to generate, for example, realistic images or other applications of this stuff. So this is the second project, and this is something a bit more involved with that. I guess there's no value for now going into deeper details, but something that's really fun and that's really interesting and I would say really trendy nowadays, machine learning. And then one third branch of research I'm working on is something a bit more pure, which is called deep learning theory, which is basically something on top of the variational autoencoders and deep learning. Because we have these big machines, they're called neural networks that basically at the basis of all or many of the machine learning algorithms that are employed nowadays in the state of the art. And they work very well in practice, but then the thing is that we don't really know how they do this and why they work so well. For example, you were explained before about the bias-variance trade-off, at least on a very high level, where you assume that you should have a model that's not too big, not too powerful, otherwise it will just interpret the data. But at the same time, you want something powerful enough so that it can model the data decently. Well, machine learning and deep learning, especially in the last 2 to 3 years, they noticed that these machines are huge. They can fit any training data set. So basically the interpretation kind of scenario we're seeing before. And still, for some reason, which is we're getting to an explanation nowadays, but still not completely clear. For some reason, they can interpret the data and generalize very nicely, meaning that, for example, they learn a data set by heart, and at the same time, they can see a new image which they've never seen before and classify it well. So this is something that I'm working on at the moment. It's part of a bigger picture about understanding deep learning and making these machines more reliable, maybe understandable. Maybe we can explain them by white boxing them in a sense. They're called black box models because we don't understand what they do, the mechanics inside them, and now we want to understand why they do it. So the classical statistical learning theory is falling a bit behind in this sense, and now in the last 2-3 years, there's a plethora of papers that try to understand what's going on with deep learning, on a more theoretical basis, to move on to applications afterwards. So this is just me explaining some stuff that I'm doing at the moment, which I hope is representative of what one could do if they chose this given path. But on a more high level, I would add a personal note, which is just to have fun doing the master. I would say that, especially given the very international environment here, something very precious to just connect with your peers and have fun in the city, because it's a very young city. And one should have fun. One, it's your life. Two, because it also improves productivity at a certain point. Well, it depends on the point, I guess, but after you've studied too much, you should also take a couple hours off. That improves productivity. So just have fun during the science master, because it's a very interesting field as well. And I guess you're gonna like it a lot. So I guess that's it.